Right, please copy down the learning objectives and onto a clean page in your class copy. And as we go through this unit of work, you need to be referring back to this to make sure that you have understood all these learning outcomes. You can pause the video at this time in order to take note of these learning outcomes. Okay, this unit of work is, as you already know, based on inequalities. So what is an inequality? Well, let's have a look at this example here. We know that when we're coming into a town, sometimes we see a speed limit of 60 kilometers per hour, and we see the circle with 60 in the middle of it, and we know what it means. And what it means is that the speed limit of the car in the city can't be any higher than 60 kilometers per hour. We could write this as speed, and that symbol there in front of the 60 is less than or equal to 60. Or we could just change the word speed into S. S is less than or equal to 60. And of course we know what this means. It means that the speed can be 60. It can be 59.9, 59.5, 58, 55, 40, so long as it's not above 60. So the statement S is less than or equal to 60 is an example of an inequality. Now, so here we've got x plus 3 equals 8. What's this? This is an equation. How do I know it's an equation? Because the left-hand side is equal to the right-hand side. However, this thing here is an inequality. So we can have x plus 3 is greater than 8. That's what this symbol here means, greater than 8. And this symbol here means greater than or equal to 8. And these two are examples of inequalities, where one side is not strictly equal to the other. It can be greater than, less than, greater than or equal to, less than or equal to. So here are the 4 inequality symbols. You have to copy down everything that's on this page. You can pause the video at this moment. You need to reflect upon it, and you need to make sure that you thoroughly understand it. It's absolutely essential that you learn the meaning of these 4 symbols. Absolutely essential. Please do so. Don't forget you can pause the video at any time and take notes. Natural numbers. You should know from first years what natural numbers are. The coding for natural numbers is either a bold N or it's an N written like this with a double line on one of either the uprights or the diagonal. It doesn't really matter. This is an example again of an inequality because the left-hand side is not equal to the right-hand side. This symbol here is greater than, and this symbol underneath it is equal to. So together we've got greater than or equal to 4, where X, this symbol here, means belongs to, another way of saying it, is a member of the set of natural numbers. If you'd forgotten what the meaning of this symbol was, when you take your notes, draw an arrow off to one side and write down belongs to. This means that X may be any or whole number greater than or equal to 4. For example, X can be 4, it can be 5, it can be 6, it can be 7, it can be 8, it can be 9, and so on. These can be marked on number lines using dots. So for example, if I wanted to put this solution set on this number line, I have to use dots, filled in dots, often referred to as closed circles. The arrow at the end indicates that this answer goes on forever. So we've got 3 going on forever symbol here, and that arrow at the end symbolizes that my answer isn't just 4 blue dots, there's an infinite number of blue dots. Now we've got integers. So we've got x is greater than minus 2, where x belongs to the set of integers the code for integers being z, revision of first year. So it has to be greater than -2. So what integers are bigger than -2? Well, -1 is, 0 is, 1 is, 2 is, 3 is, going on forever. So here is our number line. So we want to represent this answer on our number line. We just put, again, closed circles, dots. So here's our solution set, and here's an arrow at the end indicating it goes on forever. You need to copy this page very neatly into your class copies. Thank you. Pause the video to do that. Looking at the set of real numbers. Real numbers is the set of all decimals. This is a combination of rational numbers, which is the set of all fractions, and irrational numbers, which is the set of all, which is the group of all decimals which cannot be represented as a fraction. So we're looking here at the inequality x is greater than or equal to 3. Is the set of all real numbers that is greater than 3. We need to represent this inequality on a number line. So what we have to do first of all is we have to draw the number line. Once we've drawn the number line, we have to focus on the boundary point. Now the boundary point is x is equal to 3. Because it says here x has to be greater than or equal to 3, so the boundary has to be 3, and it's equal to the 3. And because it's equal to the 3, we used a closed circle. Now at this point, we need to actually get very clear in your head, what do we mean by a closed circle? We've got two different types of boundary markers, closed circle, which we just put up in the diagram, and an open circle. A closed circle is a circle that's filled in. An open circle is a circle where it's not filled in. Closed circles are associated with these two symbols, the greater than or the equal to, or the less than or equal to symbol. The open circle is associated with greater than or less than. So it's very important that when you have an equal situation, possibility of equals, you use the filled in circle, the closed circle. When you haven't got the equal to option, then you draw an open circle. What we then have to do is we then have to draw a line that represents all the answers. Because the real numbers is all the decimals, it means that it's not just 4, 5, 6 and 7 anymore. It's all the numbers between 3 and 4, all the numbers between 4 and 5, and all the numbers between 6 and 7. And the only way we can represent that is by drawing a thick line. And we have to keep drawing that thick line along until it's covered all the relevant points that we've made reference to on our diagram. Now this is bigger than 3, which means I have to keep going forever. Because I've drawn my number line beyond 7, I have to draw my filled in solution line going beyond 7. Now that I've completely covered the relevant part of the number line, I can stop. And once again, the arrow at the end indicates that this answer keeps going on forever. And I remind you once again, the reason for the thick line is because the real numbers is the set of all decimals. So it's all the numbers between 3 and 4, 4 and 5, 5 and 6, 6 and 7. The set of real numbers contains the natural numbers, the integers, the rational and irrational numbers. In summary, the bold line indicates that all the points on the line are included. The closed circles at 3 shows that number 3 is also included in the answer. On this page, we're going to explore the open circle, closed circle scenarios a bit more closely. Now, you have got to learn that the only time you use open circles is with real numbers. You can use closed circles with real numbers, with integers, and with natural numbers. But a closed circle is only used when something can specifically be equal. It's really important. So here we're going to look at a situation where x is greater than 3 and x is less than 7. We're looking at a combined solution set. So we've got x is greater than or equal to 3. And because x is equal to 3, the boundary point must be using a closed circle. In this one, we've got x is less than 7. X is less than 7. Because there's no equal symbol here, we're going to be using an open circle at 7, which has just appeared up on the diagram on the right-hand side. And now we have to shade the solution set. So looking at all the ones that are bigger than 3 but less than 7. So we start shading this line in, and all the ones that are bigger than 3 and less than 7, so we finish here. And please note what you now have is you've got a circle closed at the beginning, and you've got open at the end, and shaded in between. So that indicates all the answers in between, but the only one that's equal is 3 at the beginning, and this is not equal to 7, so that's why it's an open circle. Let's just explore this just a little bit further. Now this is a very important concept. It's fairly obvious really. If 7 is bigger than 4, if 7 is greater than 4, then 4 must be less than 7. Do write that down in English. Pause the video if you have to. This illustrates that when two parts in inequality are interchanged, the sign changes direction. So the sign is pointing towards the 4. So if I bring the 4 over to the left and the 7 over to the right, you must make sure that the sign changes direction because it must still be pointing towards the 4. So just reinforce this. If 8 is bigger than 3, the sign is pointing towards the 3, then 3 is less than 8, and therefore the symbol is still pointing towards the 3. If x is greater than or equal to 5, it's pointing towards the 5. And if we swap the letter and the number around, please note that this symbol is pointing towards the 5 still, but we say 5 is less than or equal to x. So that means this x greater than or equal to 3 could also be written as 3 is less than or equal to x. And this x is less than 7. I'm going to keep it the same way. Now, why did I do that? Well, I'll tell you why I did that. Because over here, I've got my x is less than 7. And now, my 3 is less than all the other x values. And what I can do is I can bring these together. And if I bring them together and I can superimpose one on top of the other, I can write a single answer. 3 is less than or equal to x. X is less than or equal to 7. So I can bring these together and end up with a single answer. To bring two inequality symbols together and end up with a single answer, there is a rule, and you need to write this rule down. So you need to stop the video at this point, and you need to write this down. Listen to me very carefully, I'm dictating. To bring them together, the inequality symbols must always be pointing to the left-hand side. The arrow must be pointing left. So this arrow here is pointing left. This arrow here is pointing left. These two arrows are pointing left. I cannot combine an inequality which is written pointing to the right. And if you remember that, it's a useful trick. Finishing this off, we're looking at the inequality x is greater than -2, where x belongs, the set of real numbers, is shown below. The empty circle at -2, let's have a look at the boundary point. The empty circle at -2 is used to show that -2 is not included in the answer. The solution set they've drawn in the diagram isn't very clear, so I'll make it more obvious. And the solution set, because it's bigger than -2, is off to the right, and that symbol arrow there is saying this set is going on forever. Once again, you need to pause the video and you need to write down all the notes on this page.